So first of all, I'm going to do a revision for all the rules that we have learned this week. First of all, the antiderivative or primitive. The integral of f of x is another function. Okay, so we are looking for the function, the primitive function before derivative. Okay, so the rules of antiderivative, they are only 5 rules or 4 rules, 4 important ones. One for the len and one for the exponential later on. First of all, the integral of any constant is constant x. The integral of x to the power n is x to the power n plus 1 over n plus 1. The integral of u prime un is un plus 1 over n plus 1. The integral of u prime eu is eu. And the integral of u prime over u len u. You still remember that the derivative of any len is u prime over u, and the derivative of eu is u prime eu. So those two, they are very easy to determine quickly. U prime un, it's un plus 1 over n plus 1. I have a lot of examples regarding every rule. I'm going to pass on them quickly because I need to explain the area and the integration by part. They are more important. So first of all, integral of 6 is 6x. It's the first rule. Integral of 3t squared, the 3, it's useless, so we take it outside. And the integral of t squared, it's t cubed over 3. So it's 3t cubed over 3, which is t cubed. Okay, so this is the second rule. I'm going to solve an example of the third one. This is, it should be u prime un. Okay, so what's u? It's what's inside the parentheses. It's x squared minus 1. So u prime is 2x. Okay, the derivative of u. Is the u prime found beside u to the power n? Yes, so we can apply the rule directly. It's un plus 1 over n plus 1. Okay, but what if we don't have the derivative beside it? Like here we have 1 minus 2x squared. 1 minus 2x squared, its derivative is minus 4x. Okay, so do we have minus 4x? No, I can add minus 4. Pay attention, you can add constants, but you cannot add variables. You cannot add x, okay? So minus 4x, we put minus 4 inside, as long as we put minus 1 over 4 outside. So we have to do the reciprocal of them. Now we have u prime un. So we can apply the rule un plus 1 over n plus 1, and we already have minus 1 over 4. We multiply the denominators, and that's the final answer. Okay, I'm going to go for the rule number 4, which is u prime eu. What do we have? We have u is 2x. Okay, what's 2x? The derivative of 2x u prime, it's 2. So I have to put 2 inside and 1 over 2 outside. So the final answer is 1 over 2 e to x. Another rule for len, okay? We have u x plus 4. What's the derivative of u? It's 1. Do we have 1 outside? Yes. So the derivative of u prime over u, it's len u, okay? Of course, you can solve all of these examples, but I have to go for the second objective, which is the definite integrals. When I say the definite integrals, I mean I want at the end a numerical value of the integral. So if f is continuous over ab, then integral from a to b to the function, it's integral, but then you replace b and a, f of b minus f of a. I'm going to take a direct example so you can understand it quickly. We have integral from 1 to 2 to x squared. What's the integral of x squared? It's x cubed over 3. Now I need to replace 2, which is 2 cubed over 3, minus replace 1, 1 cubed over 3, so the final answer is 7 over 3. So when I say definite integrals, I mean I have to obtain at the end a constant number. Here are some important properties. The integral from a to 8 of a function is 0. We can split the integral from a to c, c to b, as long as c is in between the interval ab. If f is an odd function, then integral from minus a to 8 of the function is 0. If f is even, then minus a to a, it's 2, 0 to a, because it's an even function. So the y-axis is a symmetric. Okay, so I have two parts, two equal parts. And here we have a lot of examples on even and odd function. Now I will start with an important part, which is integration by parts. Integration by parts, I'm going to start with the example to understand very well why do we use integration by parts. What's the integral of ln x? Okay, do you know what's the integral of ln x? No. Is it a constant? No. Is it x to the power n? No, I'm just listing the rules. Is it u prime un? Like, for example, if we have ln x, do we have its derivative 1 over x? No. So is it u prime over u? No. And it's not u prime eu. So it's none of these rules. So here we have to use another property, which is integration by part. Integration by part says if you have uv prime, integral of uv prime, it's equal to uv minus integral to u prime v. Okay, this is similar to derivative of u dot v. It's u prime v plus v prime u. It's the same thing, okay? But we are just replacing the derivative by integral. So the integral of uv prime equals uv minus integral to u prime v. So every time in this integral, you have to decide which one is u and which one is v prime. If you look at this integral, here we have to choose which one is u and which one is v prime. First of all, we said that here we have a 1. I can say that here I have a 1, right? Because ln x, it's 1 times ln x. Which one should be u and which one should be v prime? Of course, I'm going to pick ln x as u, because if I pick it as v prime, I have to do its integral. And I don't know how to find the integral of ln x. So I picked ln x to be u. So what's the derivative of u is 1 over x. And we picked 1 as v prime. What's the integral of v prime is x. So you choose 1 to find its derivative, and you choose 1 to find its integral. Great. Now we apply the rule. What's the rule? It's uv minus integral u prime v. uv, what's uv? u times v. It's x ln x. Okay, u times v, it's x ln x, minus integral of u prime v. u prime v, you need to multiply 1 over x by x, it's 1. And now x ln x is done. What's the integral of 1 is x. So the integral of ln x is x ln x minus x. I'm going to solve another exercise. Here we have x ln x. I have two functions, x and ln x. You have to choose one to be u and one to be v prime. As I told you, every time you have ln x, you have to pick it as u. So the derivative of u is 1 over x, and the integral of x is x squared over 2. Now we apply the rule, uv, you multiply u by v, you get x squared over 2 ln x minus integral of u prime v. 1 over x times x squared over 2, it's x over 2. And the integral of x over 2 is x squared over 4, because over 2, this is a constant, you put it outside 1 over 2, and the integral of x is x squared over 2. Then you multiply the denominators, you get x squared plus 4 over 4. I'm going to solve the third one also. Here we have x ex. Now, if you have ex, then you always pick it as v prime, because you can do its integral quickly. And you pick x as u because you can do its derivative quickly, okay? So here we have u prime uv minus u prime v. Also, the last one, I picked, let me clear the screen. Okay. I picked x plus 1 as u and ex as v prime. So every time you have ln, pick it as u because you can do its derivative. And if you have ex, pick it as v prime because you can do its integral. That's integration by part. And those are the most common exercises, okay? So every time they will ask you about integration by part, it's one of these integrals. I try to put all the conditions for you. Now we have the area limited. The area limited, it's always y above minus y below, and of course it's limited between two numbers. Let us take the first condition. We have the curve C, A and B. We need to find the area between the curve x prime or x equals to A and x equal to B. The area is y above minus y below. What's y below? It's the x-axis, so it's 0. So the integral is f of x from A to B unit square because it's the area. Okay, now this one, C prime, x prime, x, A and B, it's down. So y above is 0 because x prime or x in this case is 0. It's the above function. So we have minus A to B f of x d. Now, between the curve A and B and x prime or x, we have two parts. So we do A to C alone and C to B alone, two parts here. One will be y above minus y below is 0, y above minus y below, now y above is 0. So that's the final answer, okay? I tried to put for you all the examples, but I'm going to solve only the last one for you. We have a function x squared of curve C, and we have another function x plus 2 of curve C prime. We need to calculate the area limited by the curve C and the curve C prime, and x equals to minus 1 and x equals to 2. This is the shaded area. Can you see it? The shaded region, sorry, the area of the shaded region. The area is from minus 1 to 2, y above minus y below. Which one is above? X plus 2 is above, and x squared is below. So now what do I get? I need to do the integral of all of this. The integral of x is x squared over 2. The integral of 2 is 2x. And the integral of x squared is x cubed over 3 from minus 1 to 2. First, we replace 2 minus, we replace minus 1, and we get 9 over 2 units squared. That's our lesson. I've already gave you a worksheet. Try to practice it. And if you have any question, you can go back to this video to make everything clear.